Today we're in section 2.7, the perimeter and area of similar figures. Perimeter and area of similar figures. It starts on page 84. Okay, well, you need to know what perimeter is. This is more than likely something that you've learned before. The perimeter is the distance around an object. The area is the size of the surface of an object. So say I have a rectangle. Okay, the perimeter is the distance around that object. It's their borders. That's perimeter. The area is the amount or the size of the surface of an object. This is two-dimensional. The area is what fills that object. I'm sorry, take that back, that's volume. The area is basically the surface space, okay? In this case, length and width multiplied together. That's perimeter and area. So this lesson is very much a lesson on ratios. Can anybody tell me what a ratio is? I probably should have put this in the terms for today's lesson. What's a ratio? I'll give you a hint.
Did you learn that last one?
I'll give you a hint. I just highlighted it in purple. It's a comparison. So are you going to say?
Like, let's say there was like 20 boys and like 4 girls.
Yes.
It'd be like 1 girl for a certain amount.
Yes, very good. It's a comparison. All right. It's very much a comparison between two values, boys to girls, different sports, who plays basketball, how many play basketball, how many play volleyball. Okay, I'm making a comparison. So here I'm making a comparison between similar figures. That's what I see here. Similar rectangles. All right, they've got to be similar in order for the ratio to be true. If they're not similar, I cannot use ratios and proportions to compare these objects. They must be similar. So that sounds like a good true-false question. Okay? So if I said two figures do not have to be similar in order to use ratios to compare their values, that's false. They do have to be similar in order to use ratios to compare their, in this case, their side lengths. Okay? So the only other part here that's very important is the red to blue part. Because what if you do it backwards? What's going to happen to your ratio? It's going to be upside down. It's going to be the wrong order. Okay? We write ratios as fractions. So if I'm going red to blue, the first figure value goes on top of my ratio. So a 4 would go in my numerator, red to blue. If it said blue to red, then the blue value would go on top, okay? It's whatever one comes first in my comparison, red to blue. That goes in my numerator. What's the value of the similar side? That looks like a gray figure. What is wrong with my projector? That's blue, guys, I promise. It's kind of like a grayish blue. It is grayish blue, but it's still blue. What's the value of the similar side? Tell me. 6. Kid you not, this is all we do. Reduce it. 2/3. Perimeter. The ratio of the perimeters. Okay? That's all we're doing here. Again, blue to red, and I would write it in reverse order, so you got to make sure your order is right. Okay? Now you're going to practice one. Okay, now the values are hidden in this explanation. The height of a figure A is 9 feet. The height of a similar figure, ding, 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 that's my hint that I can use ratios because they are similar. Figure B is 15 feet. What is the value of the ratio of the perimeter of A to B? That's important too, because that tells me the order of my ratio. All right, go ahead and try to write your ratio on your notes. What did you get for your proportion? What did you write for your proportion? 9 over 15. So that's my final answer? No, got to reduce it. 3 over 5. 3 over 5. Okay, so that's perimeter. What if it wants me now to compare area? Okay, well, again, I need to make sure that the figures are similar. Are they similar?
Yes.
No.
Are they similar?
Yes.
Yes, they are. Okay, the problem tells me that. Find the value of the ratio red to blue. Again, it's important that we know from what figure to the other I'm comparing. So from red to blue, what is the ratio? Okay, so go ahead and put those values into a ratio. Okay, so what ratio did you write? 6 to 10. Okay. Can I reduce that? Can I reduce 6 over 10? Okay, so let's reduce it if we can. This is the perimeter. Does everybody agree? We just did that in example 1. This is perimeter. Except now it's asking me to find area. So what I need to do is I need to square these values. Okay? What does that mean? That means my numerator is being squared and my denominator is being squared. All right? So what's 3 squared? Is it 6 or 9?
9.
It's 9 because that's 3 times 3. Remember, that's not 3 times 2. So it's going to be 9 over what? 25. Sorry, that's a weird looking 9. Okay, 9 over 25. All right, so the difference between perimeter and area, guys, this is really the bulk of your homework. Find the perimeter, that's the ratio. Then one step further is to square them, and that's your area. And that's it. That really is it, okay? All we have to do now is the word problem. Okay, turn in your books to page 86. Page 86 in your books. All right, for time's sake and kind of practicality, all right, basically what's going to be practical for us to really just focus on and take from this example, we are only going to find perimeter, okay? Now, in yesterday's lesson, we talked about setting up proportions, okay? And that's exactly what we're doing here in this example, is we're setting up a proportion. You guys see the figures over on the left side of page 86, because you should be turned there in your books by now. Okay, page 86, the figure of the swimming pool and the figure of the court, okay, the volleyball court. So what I'm going to do to find perimeter, okay, is I'm going to set up a proportion. All right, whatever ratio I set up on one side, I need to make sure it matches on the other side. That's very important. So again, what I said yesterday, I'm going to kind of stick with today. I like to focus on one figure at a time. So take, for example, the pool. Okay, what information am I given on the pool? Is that the width or the length? On the pool, that's the width. So let's go width of the pool. Over, what am I solving for? Perimeter. I don't know the perimeter of the pool. P. Equals, so what would go in my numerator on the second ratio? The width of the court or the perimeter of the court? Does width go on top or perimeter based on how I set up my first ratio? Width. Because it has to match width compared to width, okay? And the numerators. So what's the width of the court? 10. And what is the perimeter? It gives me that information. 60. All right, now use your cross products to solve. All right, 10p equals, what's 18 times 60?
1,080.
Divide both sides by 10. The perimeter is 108 yards. All right, guys, and that's it for today's lesson. That's everything you need to know for 2.7, guys, and we're officially done with chapter 2. That's awesome. Yep, we're done with chapter 2.